Hello everyone, hope all of you guys are doing wonderful, and this is our experiment 12b, which is the Voltaic cells, and this is a very easy experiment. You may have watched the video already, and this is the report sheet that you have to complete. And pretty easy, straightforward. All you need to do is to find what is the anode. So when you watch the video, you have seen that the copper zinc cell and the copper lead cell, and also a copper solution, two different concentrations, 1 molar copper and 0.0001 molar copper solutions, and their voltages is written down over here. So what you need to do is you need to identify what is the anode and what is the just the anode, right? But let's see how we're going to go ahead and do this one. Okay, and this is the Voltaic cell apparatus that you had seen in your virtual lab. So you may have seen a porcelain container, and then inside it you put another container, and then the two solutions and also the two electrodes. What we have learned in the lecture, basically how a cell look like is like this. Okay, so I have explained you that you have two containers. Always the left side we put anode. So the two electrodes, so this red one is going to be your anode, and the green one going to be your cathode. So this one, the green one, is your cathode. Cathode is where the reduction take place, right? And your red one, this is going to be your anode, and that is where the oxidation takes place. Oxidation means, let's say our first cell that we are looking at is zinc and copper, right? Yeah, let's look at that. Yeah, copper zinc cell. So your anode going to be zinc. But how do you know anode is zinc? In order to find out that, you need to know their E note cell values. So the E note cell for the zinc 2 plus cell, I will give you that value, which is negative 0.76. That is equals negative 0.76. Negative, right? Negative 0.76. And then the copper cell, copper 2 plus cell, electrode potential is 0.34, positive 0.34. Remember, I told you guys when we were dealing with the lecture that the more negative electrode value, the potential is where the oxidation takes place. Okay, and then the less negative or the more positive electrode is where the reduction takes place. So between zinc 2 plus and copper 2 plus cell, since zinc is negative 0.76, so zinc going to be your anode where the oxidation takes place. So what is happening in the zinc electrode? Zinc oxidizes to give you zinc 2 plus and 2 electrons, and these 2 electrons that generate here in there, zinc goes to zinc 2 plus, and then the electrons move to here electrons. That is your electrons. Okay, also remember we talk about there is a salt bridge. So the 2 electrons are generated at the anode, electron goes to the cathode, and then what happened there, copper 2 plus take those 2 electrons and become copper. So there are copper 2 plus ions, copper ions in the solution, and here this is your zinc electrode, and you have zinc 2 plus ions, copper 2 plus ion in the solution, and this is going to be your copper cathode. So cathode is copper and anode is your zinc. And then we also put a salt bridge. I'm going to make my beakers a little bit bigger. Oopsie. So I can put a salt bridge here. So the salt bridge, so this is the electron movements, okay, and then the salt bridge, I can put a salt bridge in this color maybe. Okay, let's do purple. Okay, done. Go back now. Okay, salt bridge is this one over here. Salt bridge help you to balance the electrolytes in the two solutions. Since zinc becoming zinc 2 plus, we are adding more cations, right? So to balance that cations, anions, let's say in your salt bridge you have potassium nitrate, NO3, anions will go to the anode side. What about the cations from the salt bridge? Now what is happening in the cathode? Copper ions become copper, meaning we are losing copper ions from the solution. So the cations in the salt bridge move to cathode side. Okay, so from the salt bridge, anions, from the salt bridge, anion goes to anode. You can even remember like that. Anions go to anode, and then the cations from the salt bridge goes to cathode, right, to balance the electrolytes. Okay, so that is what we had learned. Now what you see in your virtual lab, you will see all that in this container, because now they are again physically separated, but you have one container inside another container, right? So you can have your one of the electrodes, maybe you can put, remember you may have seen in your virtual video that you put one electrode here and then you clamp it, and then you put another electrode inside the inner container and then you clamp it, and this could be your cathode, and it is going to be your copper cathode, and then the outer one could be your zinc electrode, which is going to be your anode. And then you clamp it and then you let it run, and then you let the voltmeter to stabilize, and then you read the voltage, and that is what you had seen over here. In the copper zinc cell, EMF is 0.8. Now how do you calculate E naught value? Remember, you guys learn E naught cell equals E naught cathode minus E naught anode. And the first cell, which is going to be your zinc copper, zinc is going to be your anode, cathode is copper, and the value for the copper is 0.34, and then the value for the anode, which is negative 0.76. So 0.76 plus copper zinc, yeah, that's right, copper zinc, it's going to be 1.10 E naught cell, but it is being reported as 0.8, let's say, which is close enough, right? So the copper zinc cell, what is the anode? Anode is going to be zinc, right? Similarly, you can do for the copper lead, and then the value for the lead is negative 0.13. Pb negative 0.13, that is the E naught value. And again, between 0.13 and copper is positive 0.34. Which one is going to be your anode? Again, your anode is going to be lead because it's more negative value, and then the copper going to be your cathode. Okay, And that's how you're going to find out that. And then the last one, you have 1 molar copper solution and 0.001 molar copper. Now in this one, which one going to be your anode, which one is going to be your cathode? Remember we talked about concentration cells. So in the concentration cells, what is happening? One is going to utilize the concentration, and then the other one, you are releasing more ions to the solution. Okay. So what is happening over here when you have 1 molar copper and 0.001? Let's say both of these electrodes are copper. You have 2 copper electrodes. I'm going to go ahead and erase some of these ones. And both of these are now copper in the concentration cells. One is going to have a higher concentration, and then the other one is going to have a lower concentration. Always the cathode, where the reduction takes place, will have a higher concentration, and then anode, where you have lower concentration, that is going to be your anode, where the lower concentration. So if you look at what is happening in the cells, so let's say both of these are copper. Both of these are copper. So you have one copper rod over here, you have another copper rod over here, but the solutions have different concentrations. Let's say this is the outside one, this is 0.0001 molar, and then the inner one, let's put 1 molar. Okay, let's say a 0.001 molar copper solution. What is happening here is copper solid becoming copper ions, Cu2++, 2 electrons. And then the 2 electrons that generated goes to this side. So the copper 2+ ions take those 2 electrons and become copper in the cathode. And this is going to be your anode. So what is happening in the anode side? It is releasing copper to the solution. You see copper metal becoming copper 2+. So having a lower concentration for where the oxidation happens is quite okay, because you are releasing copper ions to the solution. Whereas the cathode need to have a higher concentrated solution, because now the copper in the solution as copper ions takes up their 2 electrons and become copper metal as the reduction. So between 1 molar copper and 0.001 molar copper, your cathode is going to be the one that has higher concentration, 1 molar concentration. Okay, so that's what you need to answer. Which one is the anode? So between copper and the zinc, your anode is going to be zinc. Between lead and the copper also, your anode is going to be lead, because it has a higher negative electrode potential. Between 1 molar copper and 0.001 molar copper, your anode is going to be the the higher concentrated one, which is 1 molar copper solution. Okay, so that's what you need to answer for this experiment. Okay then, talk to you soon. Bye bye.